Today we are doing Algebra 2, Lesson 5.5, Completing the Square. We're solving quadratic equations by completing the square, and then we're writing quadratic functions in vertex form. Completing the square is a process that allows you to write an expression of the form x squared plus bx as the square of a binomial. So what we're going to do is we're going to take trinomials like x squared, like ax squared plus bx plus c is equal to something, and we're going to find a new value of c that allows us to complete the square. What we've looked at previously with this is we've looked at shortcuts when there's a perfect square for a. So as for example, you had 4x squared plus, we're going to leave it say bx for a second, plus another perfect square for c, 9. So if there were two perfect squares, remember you said you could take the square root of this part and call it 2x, and you could take the square root of this part and call it 3. Then we said the sign that goes in between 2x and 3 is the sign that's in front of b here. So plus 3. That entire thing will be squared. We're going off of that today with completing the square. Example number 1 is find the value of c that makes x squared plus 12x plus c a perfect square trinomial. Then write the expression as the square of a binomial. So in the expression x squared plus 12x plus c, notice what b's value is. B's value is 12. So all you do is take that value 12, divide it by 2, and square it. And that gives you your new value of c. So 12 divided by 2 we know is the number 6, and 6 squared is 36. So our new value for c when we're completing the square is going to be positive 36 or plus 36. Use this value of c to write x squared plus 12x plus c as a perfect square trinomial, and then as the square of a binomial. So here's your perfect square trinomial. Notice the only thing that's different from black to red right here, x squared plus 12x plus c, is that instead of saying plus c, it says plus the new value of c, 36. Then, once you have this perfect square trinomial, you simply take the square root of this one, which is x, and the square root of this one, which is 6. So x and 6, and then this is the sign that goes in between them. So x plus 6 squared. That is the square of the binomial. That is that perfect trinomial x plus b over 2 squared. So let's look at another example like this on the back. X squared minus 3x plus c. On the back, find a new value for c. C is equal to b over 2 squared. So take about 20 seconds and find that answer for me real quick. B over 2 squared. Give me a new value for c. Okay, negative 3 is not as easy of a value because it's not even. So when you take this value of b, it's negative 3 over 2, and then square it. You're not getting an even value, so you have to make sure to square both values. Square negative 3, and you get positive 9, and square 2, you get positive 4. So your new value for c is 9 over 4. Let's continue with that problem. It says, then write the expression as the square of a binomial. So first off, let's rewrite it as a perfect trinomial. It says x squared minus 3x plus c. But our plus c value is going to be the new part that we plug in. So right here, what is our new value for c? And it's positive 9 over 4. So from there, it says write it as the expression as, or write this expression as the square of a binomial. Take about 10 seconds to see if you can figure that out. Remember, square both of them. Take the square root of both of them. So again, I know this is new stuff. This is a perfect trinomial right here. So you could take the square root of x squared, x, and the square root, as bad looking of a number as that is, 9 over 4, it's two perfect squares. So the square root of 9 over 4 looks like this. Remember, the square root of 9 over the square root of 4, which is 3 over 2. So the square root of 9 is 3. The square root of 4 is 2. So that's your binomial, x and 3/4. This is the sign right here in front of b that goes in between them. So x minus 3 over 4. And then that entire binomial is squared. See how it says to write it as the square of a binomial? X minus 3/4 squared. I know this looks very different and very confusing the first time you look at it, but this is actually one of the easier things we do in Algebra 2. 4 squared is 2, excuse me. But again, this is one of the easier things we do in Algebra 2. I know it looks confusing at first. With some repetition, it gets very easy. Okay, here's another one. X squared minus 5x plus c. So the first thing we need to do is we need to find a new c. C is equal to b over b over 2 squared. Now don't let this confuse you, because look how it just confused me a second ago. B over 2 squared, it confused me a second ago because when we were graphing our quadratics, we said x's value, or that line of symmetry, remember, was negative b over 2a. So it's easy to confuse those two because notice these little formulas are very similar. So right here, if we take b's value, our b's value in this case is negative 5. So negative 5 over 2 squared. Again, this is an odd number, so we're not getting a nice, pretty integer number. We can still square both of them, though. We can square negative 5. That means negative 5 times negative 5, which is positive 25. And we could square 2. 2 times 2 is 4. So our new c value is 25 over 4. When we rewrite it as a perfect trinomial, it's going to say x squared minus 5x plus c, our new value. And our new value we just got was this one right here, positive 25 over 4. That's our new c value. And then the last part is to write it as the square of a binomial. So all you do with that one is take the square root of this, x, the square root of this, that means the square root of 25, which is 5, and the square root of 4, which is 2. So 5 over 2. This binomial is minus in between them, and the entire thing is squared. So x minus 5 over 2 squared. That is the expression written as a square of a binomial. Example number 2 is solving a quadratic equation. Okay, so we have 2x squared plus 8x plus 12. First thing you want to do is you want to factor out any common factors. Notice all of these have the number 2 in it. So you can divide the entire equation by 2. You can divide this by 2, this by 2, this by 2, and even 0 can be divided by 2. You're still going to get 0. So when you divide by 2, notice you get x squared plus 4x plus 6 equals 0. Now, this is not a perfect trinomial because you cannot take the square root of 6. That's what makes it not a perfect trinomial. Since it is not a perfect trinomial, we have something that says x squared plus 4x plus 6 is equal to 0. This is the one that you can't take the square root of because it's not a perfect square. So, algebraically, how would I move plus 6 to the other side of the equal sign? How would I do that? You subtract it. Yeah, algebraically, it says plus 6. You subtract 6 on both sides. So when you subtract 6, you're going to have something that says x squared plus 4x plus c, we don't have it anymore, is equal to negative 6. And now we can find a new value for c. So in order to find your new value for c, remember c is b over 2 squared. B's value in this case is 4. So 4 over 2 is 2. And 2 squared is positive 4. So your new value for C will be positive 4. But here's the thing. Once you have a new value for 4, or for C, you can't just add 4 to one side of the equation. What do you have to do if you add 4 on one side? You have to add 4 to the other side. So you have negative 6. You have to add 4 there as well and get negative 2. So now it says x squared plus 4x plus 4 is equal to, this is the part where you're adding 4 to both sides, negative 2. Okay, so let me write it right here on the side. X squared plus 4x plus 4 equals negative 2. Now we have a perfect trinomial. Now we could take the square root of this one and get x, and the square root of this one and get 2. So in the next line, notice it says x plus 2 squared is equal to negative 2. So now we did just like this on bell work earlier. X plus 2 squared equals negative 2. Undo squaring something by taking the square root of both sides. So you take the whole square root there and there. And now you have x plus 2 equals both positive and negative. The square root of negative 2. We know how to undo that negative under that radical. We multiply it by what? How do you get this negative out? We did this last week. Multiply by I. So now we have x, undo plus 2 on both sides by subtracting it. So x is equal to negative 2. Remember, standard form is a plus bi. So x is equal to negative 2 plus or minus I times the square root of 2. And again, I know this looks confusing the first time you do it, but we've actually been building all these pieces over the last few weeks. It gets easier. Much, much easier. Let's look at another example right behind it on the back, everybody. Solve this one by completing the square. The first thing you need to do is find a new c. This c right here is not good, negative 8, because it's not a perfect square. So move that one over and then find a new c value. Let's take about 30 seconds to do that, and then we'll pick up with that next part. Okay, what we want to do is we want to get this c out of here. It's no good. So undo minus 8 by adding it to both sides. So now you have x squared plus 6x plus c, that's the unknown, is equal to 0 plus 8 is 8. All we did was moved it over. Find a new C value by using your B value 6, dividing it by 2, and squaring it. 6 divided by 2 is 3. 3 squared is positive 9. Remember, if you add 9 to one side, you have to add 9 to the other side. So now what we have is a perfect trinomial. X squared plus 6x plus 9. That's a perfect trinomial. Is equal to 17. So now, take your perfect factors out and write this perfect trinomial as the square of a binomial. Take 20 seconds to do that. Okay, so take the square root of this, x, the square root of this, 3. This sign in front of b goes in between them. So x plus 3 squared is equal to 17. Now, if we want to solve for x, we undo x squared by taking the square root of that side. It cancels this out. Square root of this side to balance it. X plus 3 equals the square root of 17. And then to get x by itself, subtract 3 on both sides. Remember, you don't get 14 because they're not like terms. X is equal to negative 3 plus or minus the square root of 17. That's what x is. And we'll pick up the second part tomorrow.